least squares line for the relationship between the number of pounds overweight and the age at death is given as y hat is equal to negative 0.538x plus 63.085. Find the 90% confidence interval for an average woman's age at death, given that the woman was 20 pounds overweight. We have n equals 20, x bar is equal to 8.9. The sum of square for the x's is 29, or 2,933.8. And finally, we have an S value of 5.3753. Okay, so they're asking us to find the 90% confidence interval for an average woman's age at death. Okay, so we're looking for the confidence interval to estimate the average age at death for a woman who is 20 pounds overweight. Okay, so in this case, it's just a regular confidence interval. We're looking to estimate the average woman's age at death. So we're not looking for a specific woman's age at death, given that she was 20 pounds overweight, but rather for the average. So the first step we're going to do in the confidence interval is normally to record the data. Well, that's been done for us. So I'm going to go ahead and just do the following then in the first step. I'm going to write down alpha. Because it's 90% confidence, alpha is 0.10. And then at that point, the next thing I want to do is to take the equation they gave us, write it down, and I want to fill in the x value that they provided to us so that we can get the point estimator for our problem. So I'm going to write minus 0.538 for x, I'll put a space, plus 63.085. And in that space, I'm going to put the woman's amount of weight overweight. She was 20 pounds overweight. Let's plug that number into our calculator then, or those numbers, and see what answer we get. So I have minus 0.538 times 20 plus 63.085. When I'm done with all that, I get the answer that y hat is equal to 52.325. Okay, so that's our point estimator for the problem. In our next step, what we want to do is to come up with our table value, our critical t table value. So in step 2, we'll do t alpha divided by 2. Now, in our case, the alpha divided by 2 value would be 5%, so we'll be looking at t.05, and we have degrees of freedom n minus 2. So n is 20, so our degrees of freedom will then be 18. Let's go look that up and see what we get. So we're looking at 0.05 with 18 degrees of freedom on our t-table. Okay, so if we're looking for 0.05 and 18 degrees of freedom, so we find the answer 1.734. Okay, so our critical table value is 1.734. All right, so we need that t-value in our next step, which is the step that we calculate the margin of error in. Okay, so remember our margin of error formula is basically t alpha divided by 2, s times the square root of 1 over n plus the fraction xp minus x bar squared over the sum of squares for the x's. Okay, so let's try to fill this information in our problem and see what we come up with. Our t alpha divided by 2 value is 1.734. Our s value given in the problem is 5.3753. Then that will all be multiplied by our square root here. Our square root is 1 over n, that's 1 over 20, plus the fraction xp, that's our predicting x value, that's 20, minus the x bar, we see that's 8.9, quantity squared, and then divide that by the sum of squares for x's, which is 2,933.8. All right, let's see what this works out to be in our calculator. So we'll have 1.734 times 5.3753 times the square root of 1 divided by 20 plus parentheses 20 minus 8.9. And then from there, we're going to close that up, square it, and divide by 2,933.8. Okay, so when we work that out, we end up with the answer 2.827. 2.827. Okay, and it goes on and on and on, of course, but we're going to store that in our calculator for later use, so I'll hit store X. That way I don't have to worry about rounding it until the very end. All right, and then our last step of the problem, our final step, is step 4, to fill in the interval y hat minus the error, comma y hat plus the error. Okay, so from here, once we have this set up, we're going to just plug in the number we got in step 1, which is 52.325 minus our 2.827, and then it'll be 52.325 plus 2.827. All right, and with that, we're going to take that answer and then enter that into our calculator to come up with our final interval. So we're going to have 52.325 years minus the error, and then the same thing, but plus the error. And so our final solution works out to be 49.50, let's say, up to 55.15. All right, so those are the number of years, and in our interpretation, we're going to say that basically we are 90% confident. We are 90% confident that the true average, now looking at our information here, it says the true average age at death for a woman 20 pounds overweight is between and that's our interval then. It's between 49.5 pounds to 55.15